Good afternoon, everyone. Welcome to the 8th Pale Blue Dot lecture series. It's my pleasure to introduce today's speaker, Professor Rajesh Sundaresan. Rajesh Sundaresan received his BTech degree in electrical engineering from IIT Madras in 1994 and the MA and PhD degrees in electrical engineering from the Princeton University in 1996 and 99 respectively. Professor Rajesh Sundaresan is currently a professor in the Department of Electrical Communication Engineering and an associated faculty at the Robert Bosch Center for Cyber Physical Systems at IISc. He is also the current Dean of the Division of Electrical, Electronics and Computer Sciences at IISc. His research interests include decision theory, communication, computation, and control over networks, cyber social systems, and data-driven decision framework for public health responses. So I'm also happy to inform you that I was fortunate to have him as my PhD supervisor at IISc, who shaped me, who shaped my research career. So without further ado, I request Professor Rajesh Sundaresan to take over. Thank you very much.
Thank you very much for this generous introduction and also for inviting me to give this talk. I see that there have been very many distinguished speakers in this particular series. Thanks for inviting me to this. I'm going to speak about something which is a little different from perhaps what you would think of coming from a science and an engineering person. It's actually something that involves bringing a little bit of mathematics into social systems and trying to see if we can maybe change behaviors and things like that. And so I'm going to give you some examples. I'm going to begin with some examples. And then there is one particular example that I will go into in some detail. And then we'll have plenty of time for questions. So I'm now going to show a certain picture, and I want you to perhaps tell me what you see in that picture. So this is the first picture. So what does this picture tell you of what is happening here? Would anyone like to volunteer? You have to speak a little loudly. Yeah. You see a policeman, a traffic policeman. The traffic policeman is pointing to something, and the traffic policeman is probably saying something to some of those that are on the two-wheelers. What might the traffic policeman be saying? So actually it is something that we see often at traffic intersections. We see that very often at intersections there is a red light, which is a stop light, and yet there are many individuals that actually go past for various reasons. And I think here the traffic policeman is saying, look at the signal is saying red, you're not supposed to go. Okay? And this would be something that one would like to see avoided at traffic signals, because if the traffic signals are orderly, then it's actually beneficial for all the individuals concerned. Not exactly, in the sense that if you look at some individuals, they could benefit by going a little, by sneaking in and getting to the other side. But then if everybody does that, then I think it's actually better if everybody is working in an orderly fashion. For example, if you look at this particular picture, in this picture, things do seem a little haphazard. It's a 5-road intersection in Bombay. But you can see that things are actually reasonably organized. For example, the traffic that's coming from that side is all stopped there. The ones which are flowing are the ones that are flowing either here, or the ones that are flowing there, or the ones that are flowing straight. This particular one which wants to get into either that road or to the left here, they are stopped. And there's also another flow there. So in some sense, this is actually orderly traffic. And what perhaps might have made this particular traffic somewhat orderly? Well, I think you can get a sense that the individuals here are to some extent recognizing that if everybody jumped then perhaps it can be chaos, it can lead to chaos, and none might be able to get forward. But there is actually one way by which we have seen at intersections um, orderly behavior can be induced, can be encouraged. And this picture will sort of tell you. So here is something where what does this say? This says that if you stop, there is a stop sign, and the stop light says that you're going to be there for 50 seconds. And if you're there for 50 seconds, then most people say that yes, this is a reasonable time. And in fact, they often turn off their scooters and cars to save petrol during this period, and then turn to something else during these 50 seconds. And in some sense, giving this additional information is something that induces positive behavior, where the person is willing to wait at the traffic intersection. Absent this information, if that 50 is not indicated, then there is a lot of uncertainty. You don't know how long you have to wait, etc. And that induces individuals to jump the red light in some sense. And so giving some information can help. How about this? But perhaps not giving too much information. Because if you have to wait there for 999 seconds, that's actually an indication that you don't know how long you have to wait there. Then, or maybe that 999 is indeed the number of seconds. That's about 15 minutes plus. So this individual is going to get frustrated for sure. And so if this is the situation, then perhaps the kind of information that needs to be provided is something which is not exactly 999, but perhaps it's more than 200 seconds or something like that. And so here is where what the topic of this particular talk, which is information design, comes into the picture. What kind of information should you provide to the user to induce pro-social behaviors and so on? Here's another example. I think all of us have perhaps used rideshare apps at some time. Here is the Uber app. I took a snapshot of my phone yesterday and got this particular picture. Let's say that you you book a car to take you from one particular location to another location. Within a few minutes, something happens. Would anyone like to perhaps share their experience of what has happened? There could be cancellations of these taxi rides. There might also be perhaps other things that happen. How many of you have gotten a call immediately after you booked a cab? Raise your hands. Okay. And this call is often seeking information as to perhaps where you are headed. How many of you have had this call? Where are you headed? So please raise your hand. Yeah. So why do you think that is happening? Why you have indicated where exactly you want to go. The app knows it, but yet you receive this call from the driver, from the taxi driver. Why do you think the taxi driver is calling you? How many of you think that it's deliberate? How many of you think that the taxi driver is calling just for the sake of calling? How many of you think it's deliberate? The taxi driver does want to know. There are a few. How many of you think that this is just to gauge whether this person is a serious traveler or not? Okay, there are one or two individuals that think that. The reason why the taxi drivers call is that they are not supplied this information. They're not supplied this information because often what happens is that when you supply this information, taxi drivers are also optimizing the best possible use of their time. And what they would like is not a short ride from the guest house to perhaps the IIT main gate or something like that, which would just be a very short ride. And they would have to come all the way from wherever they are, do this ferry and not earn that much during this period. On the other hand, what they would prefer is a long ride that takes from one end of the city to another, particularly in a town like Bangalore, for example, because then that keeps them engaged for a longer period and also assures them an income that is much bigger. And so, why does the taxi driver call you to find out where you are headed? Because I think they are looking at whether giving you this particular ride is best for them. At least are you headed in a direction that they are headed in? And if you look at it from Uber's point of view or these rideshare providers' point of view, what they are looking for is maximizing, to some extent, the driver's convenience also, but to a greater extent, perhaps customer satisfaction, because ultimately their business is dependent on the customer being satisfied. And so this information is sort of not given to the Uber drivers. And is that the right way to do this? Maybe a way to provide the information to the driver is that this is a ride that will fetch you over 200 rupees or under 200 rupees, but not more information. Is that the right thing to do? How do you design this information is an interesting question to address. Here is another application where, again, some sort of information design is something that can lead to useful outcomes. So on the left, here is a room which probably is a good room with a mean rating of 9. And let's say you're coming to Palakkad from Bangalore and you have to book a room for your stay. And you're looking at on the internet, maybe one of the room booking sites for which room is better and so on. And if you have used these apps, there are also ratings that people provide for each of the rooms. And so perhaps this room on the left is a room with a good rating, with a mean rating of 9 out of 10. That means that it's probably something that a lot of people found quite good. And on the right is another room. Let's say that when you have people go to that particular room, on the average, the mean rating of that is 7. Now, when you are a user and you are booking this particular room, for example, you would like to know that this has a mean rating of 9 and this has a mean rating of 7 and so on. Why is that? Because then you would essentially book one room or the other depending on your convenience. Often there are also other considerations. The one which is rated 9 might be more expensive. The one which is rated 7 may be less expensive. And you trade off the convenience with perhaps the cost. The cost is usually an important consideration for us. The actual ratings are actually random, because suppose there is a person that goes to this particular room, has booked this room and goes to this hotel. Sometimes this person might give a rating of 8, sometimes this person may give a rating of 10, sometimes it might be even poorer and so on. Now, similarly for the other one, these are random because depending on the particular experience that that person has had. So new customers to these internet booking sites are shown these ratings and they pick a hotel, one or the other, and they stay in them, and then they go back and give ratings so that other new users can get the right information. For example, it could be that the first one had ratings 8, 10, 9, 8, 7, 10, and the second one had 8, 7, 7, 6, 8, 8. And suppose the cost of both of these were the same. How many of you would pick the room on the left? Please raise your hand if you would pick the room on the left. And how many of you would pick the room on the right? Okay. So the room on the right has, there are actually more people that are picking the room on the right, which is surprising. The room on the right has a lower rating. The rating is poorer compared to the room on the left. The cost is the same. But for most people that are economizing and looking at the best facility within this would pick the room on the left. But the audience poll here suggests that the room on the right might be the better one. I'll ask this question again. How many of you will pick the room on the left? Okay, and how many of you would pick the room on the right? Okay, so now it's a little reduced and skewed towards perhaps what I would do as well. I would pick the room on the left. But in this scenario, there is actually a danger to providing all of these ratings to everyone that comes to see these rooms, and I want to highlight that. And so here is the danger. Suppose that the first few showings of this room, on the first few ratings of the people that went, maybe they had a poor experience. This is actually the good room with a rating of 9, mean rating of 9. But then the person that went there on the first occasion, the views from the room were not great. Wooden floor and suite room should be cleaner, and gives a rating of 5. This is a person that wants everything spick and span, and there are individuals like that. and then they have not had an enjoyable experience, despite on the average this being better, and a 5.0 rating. Another person goes there, and the person says, "We were not happy with the hot water time restrictions. It does not work for people with babies and kids. People make it, please make it available at least until 10 a.m. in the morning," and a rating of 6. Okay? And so it's unfortunate, but the first two perhaps did not enjoy the experience as much as perhaps what on the average people would have done over a long run. But then this is a new hotel, and while we somehow have the information that it would be 9 on the average, the first few ratings are somewhat poor. And let's look at the second one. The average rating is 7, and let's say that by chance people had good ratings there. Initial experiences were good. Nice and comfortable stay in the center of Palakkad. Wonderful location in the center of Palakkad. Rooms are spacious and well furnished, etc., etc. Staff is very attentive, and a rating of 8. Average is 7, but this person gave a little higher. A good place for family stay. However, the rate per room is high compared to the facilities, and this person gave a rating of 7. And let's say that a few others, seeing these two ratings, gave 7 and 7. Okay, so those are the ratings that are there. And I present these to you. The ideal is, what would be the ideal? The ideal is if on the average, the people find that the first one has a rating 9, then that ideal number is something that should be presented to the people that are deciding where to go. On the other hand, what you get to see is only what people have rated. And what people have rated is 5 and 6 for the first two, 8, 7, 7, 7. And now you have to make a choice. And you go there, and let's say your rating is 7. You pick the second one because the second one seems to be better, and you pick a rating of 7. And then the next person comes. The next person is shown your rating as well. What would the next person pick? The one with 7. Because the other two, by chance, had poor ratings and they were there. The long run average would have been 9, if only more people had gone there. However, because all of this information is provided, especially in the beginning setting, things can get locked on to the suboptimal rooms. So the one with 7 rating is something that people might start picking and going towards. So the second room somehow had initial luck, and that persisted. And the first room never got a chance to recover and see its true average. And it became a victim of random chance. And this happens in real life often. Things get selected not because they are probably the best technology or not because they are the best room in this context, but because the initial things turned out to be in their favor. How do you ensure, as people that are designing these systems, what we would like to do is get the best entity to win. If the underlying true number, intrinsic one, is 9 for one and 7 for the other, then we must somehow let people discover the 9 and the 7. Yet, we don't give people a chance to discover the 9 at all because of an initial random chance that put us in some direction. And so, information design, once again, can help. Should you present all of it to a new customer? Because maybe there is some flaw in that particular design. What I'll now do is maybe look at one example in a little more detail, and we'll see a lot more interesting things about this. And I want to highlight the key idea being mathematics can come to help us understand this and also to help us design things better. So, okay, so let me begin. Here are some list of activities. There are actually lots of activities that we do which are largely based on voluntarism, and I'm going to dwell on that quite a bit. And yet, these are things that we do without any recognition for those things. And yet, if we don't do it, the world is that much poorer. Our pale blue dot becomes, the fabric of our society and our pale blue dot becomes that much poorer. And these are some of the examples. Amongst the faculty here, you would have been reviewing papers. You review papers in an anonymous way. Nobody knows that you have done other than perhaps the editor-in-chief of, or the editor that has assigned the paper to you. reviewing of papers is something which is often thankless. Running a society's activity, there are many students among you, you're probably staying in apartments, your parents are part of the apartment society that runs the apartment's activities, the maintenance and so on. That's also another thankless job. And yet, we do this without much recognition. Or for those that are on the professional side, we might be members of the Association for Computing Machinery or the IEEE or similar other societies, and we do a lot of activities for them. And that's also something that often goes unrecognized. Or faculty time in committees, again I'm speaking to the faculty here, or mentoring junior faculty. Or for those that among the students you would have used Wikipedia, this knowledge didn't come just by itself. There are volunteers that have actually worked day and night to be able to put this content, verify that the content is correct, it's reliable and so on. And often that also goes without much thanks. Going green by reducing electricity consumption. You have often we turn on the air conditioner, but we recognize that perhaps this might not be a sustainable option, and we might want to essentially not use the air conditioner as much, or we might put solar panels on our home rooftops, or we might move to perhaps more eco-friendly vehicles, or use public transport, or give time or money in terms of volunteering. Go to a local school and help things out there, or maybe give contributions, donations, and so on. These are all examples of volunteerism. An individual volunteering time and effort towards this is what I call as someone that's engaged in pro-social behavior. Now, if you look at the distribution of the population that's engaged in this kind of activity, on the abscissa or the x-axis, we have pro-social actions and the level at which perhaps an individual might be performing pro-social actions. And on the y-axis is what is called density. The students might be familiar with this. For example, in a class, you have an examination. What is the marks distribution? You can actually put them in the form of this distribution. What fraction of the students in the class got marks between 60 and 65? What fraction got between 65 and 70 and so on? And you can put a distribution like that, a curve like that. Or you can also turn that into an equivalent one, which is an integrated version of that. So here it's what is the number between 60 and 65, whereas that number is an integral of this, and it asks the question what fraction, or it answers the question what fraction of the population have gotten less than or equal to 60. And then you ask the next question, what fraction has gotten less than or equal to 65, and so on. So that's what is called the cumulative distribution function, and both have the same information. If you look at a population and measure their pro-social actions, the number that contribute time towards a certain activity, etc., it might have this sort of a distribution. The right, as I said, is something that encodes the same as the left. If you're a class teacher, if you're the leader of your class, if you're a department chair, if you're a school principal, and then if you're a department chair in an institute, if you're the dean of your school, if you're the rector of a university, if you're the PM of a nation, or if you are perhaps, let's say, UN's General Secretary, you're actually looking to see how to increase the level of pro-social behavior among your citizens, in some sense. And so what we would like to do in those roles is to shift things to the right. When you shift things to the right, what that means is that the fraction that are between, let's say, marks 60 and 65, they are now pushed to marks 70 and 75. That's like an improvement of the class performance in the examination. Similarly, an improvement in the pro-social actions. More planting of trees happens. More activity towards time for students who are disadvantaged and so on. And so there are many such things that we would like to do to push things to the right. In terms of the cumulative distribution function, there is a shift to the right there, which means that there are more that are engaged in some action and fewer that are engaged in actions which are of a lower activity. There are many ways to do this. We would, in those roles that I mentioned, you would like to get people to do more. But there are ways by which you can enable this. For example, it can be done by diktat. External forces can come and say that you should do this. For example, that's what has happened with the corporate social responsibility law. This is a law that it's an amendment to the Companies Act of 2013. And it said that corporates must invest 2% of their profits towards perhaps poverty alleviation, towards better health, towards gender inequity and some sort of alleviation towards that, and maybe towards eliminating hunger and many such things. And that's like a diktat. You have a law, you have to comply with that. People should engage in these activities. Or it could be that every employee must spend 1 week of their time as time to give. This is also there. For example, in India, Cisco India Private Limited has this as a requirement that there is some time to give, or they encourage their faculty to provide time to give, and then they provide incentives for that. Or there could be a memo asking employees to take pledges that they will spend a certain number of hours towards some pro-social activity. And I'm sure all the colleagues, faculty colleagues, have seen such memos issued to us. Or it could be that students must send 2 classes a week on SUPW. I'll not expand SUPW, but towards that particular activity. Now, these are all diktats, external forces. And often what happens is that they take a long time to take root, or they fizzle out quickly. For example, the corporate social responsibility law is something which has been successful. However, perhaps most others are token activities. They were active for some time, but I think now perhaps we don't pay as much attention to them as perhaps the first time they were issued. Can you think of ways and means by which you can make these sustainable, these pro-social, increase in pro-social action sustainable? And the way to do that is, if these are called nudges, if you can nudge and manufacture that nudge from within, somehow intrinsically we should be doing this by ourselves. And if there is an intrinsic motivation to do this, then there's nothing like that. And what I would like to speak about is maybe leverage the social network and also human nature and get a perhaps more immediate but also lasting effect. And let's see how to do that. How to increase. If you actually look at this picture and say, I want to shift things to the right, that diktat kind of ideas is the first thing that comes to mind. But I also mentioned that those are not things that we can rely on that much, although there have been some successful ones. But if you actually think of it in a different way, you have to wear a different hat. You have to think of perhaps what might be called micro motives that lead to macro actions. Then maybe you can address those micro motives and influence the macro actions. And then something more can be said. So let's enable some information sharing and increase positive social outcomes. And here comes some mathematical modeling of a social system and perhaps how things might be improved. So an example here, and perhaps this slide would be something that requires a little bit of time that I should spend on. Here is a certain perspective, a somewhat cynical view. And the cynical view is even those that are actually doing quite a bit of pro-social activity are perhaps optimizing something. They are agents, they have some interests. Agents are those that are essentially acting by their own will in some way. And they're optimizing something. What are they optimizing? They're optimizing some payoff. There is some benefit that they get out of maybe the outcomes, but there is a cost to their actions. And you look at the benefit and the cost and you trade them off. So consider a population of individuals, the people in this particular room. And let us say that all of us, we have a certain level of pro-social action and there was a distribution of that. But now I'll separate out this action from something that is perhaps intrinsic. And this intrinsic is to what extent you are oriented towards a little more pro-sociality. That's what is called intrinsic motivation. And I'm going to call that as W. So I'm going to index all of us by the index I, and then the W would be the intrinsic motivation. For example, in your class, the class leader would be somebody whose intrinsic motivation towards pro-sociality is probably quite high compared to the others. And such a person is probably likely to work towards the class's overall benefit. And I see some people closing their eyes. Perhaps they are the class leaders in your class as well. So maybe there is a distribution of intrinsic pro-sociality, and this is something that's hidden. Nobody sees it. You see it, but nobody else sees it. Others see it only through your actions. There are those that do good things, more good things, and more support towards others, and perhaps they have a higher pro-social, intrinsic pro-social motivation. There are others that stick to their activity, and perhaps their pro-sociality or intrinsic pro-sociality is somewhat on the lesser side. And then there are actions, which are things that we observe. But these actions are such that there is a benefit that this individual gets thanks to the person's intrinsic motivation and the action. But there is also a cost to the action. And that cost to the action is something that I've encoded as C of AI. And usually costs are such that if it's a little bit, it doesn't cost that much. But if you have to increase your level of activity towards this, it costs a lot more. And 1/2 AI square is something that's quadratic. So it increases, and we have to think about positive actions. It increases. The more the positive action, the greater the cost. It takes more time away from you for you to be able to provide that. And this is a sort of a natural cost that one can think of. But then there is also benefit. If you employ an action A, or you're the ith individual, AI, your intrinsic motivation towards pro-sociality is WI, then you do get a benefit. The more the action AI, then the multiplier is WI. That's the model that we have. But then for more action, you get more benefit, but you also have to take into account the cost, and the cost comes in as a negative quantity here. So WI AI minus 1/2 AI square. That's the payoff. Okay. And so let's say that you are here, you know what your WI is. If you take action AI, you're going to get a reward WI AI minus a cost 1/2 AI square. And you are an optimizer, and this is the cynical view that I mentioned. What's your action going to be? You're going to maximize this utility. You can maximize this utility by taking a larger AI, but then you have to trade off the cost. And so you can optimize this, and the way in which you optimize this is where is the maximum? This is a quadratic function, and very quickly you can see it's also a quadratic function that has this up and then a down shape to it. And therefore, there is a point where it is a maximum. And you can check that the point where it is a maximum is AI equal to W. You're optimizing over AI. And the maximum optimum solution is actually at AI. The action that you will take is the intrinsic motivation. And so here is a model where we have, in some sense, explained or found a way to understand what each individual's intrinsic motivation is by looking at the actions. The solution to this, if every one of us is an optimizer, is AI equal to our intrinsic motivation. And our actions speak louder than our words and makes visible what our intrinsic motivations are. So the WI is equal to AI. But the important difference between this, it's the same as before. You see that the action is just the intrinsic pro-sociality. Earlier we were just looking at it as pro-sociality, but now we have separated it and we have sort of matched the intrinsic pro-sociality with the actions. But they are different. The actions and the pro-sociality, the intrinsic motivation are different because in a different circumstance, the actions, the costs, etc. might be different. So what utility is this? What use is this? Can you improve things a little based on this? And indeed, yes, it gives us an opportunity to do something. The intrinsic motivation, first a few observations. The intrinsic motivation is actually a private variable. It's something that you're aware of. Maybe you're not even aware of it in some sense, but it's sort of something that uh, you might have an inkling, and others might not have an inkling, or they get clues only from the actions that you perform. It's the high intrinsic motivation, or the W, that makes a teacher T care more about their students, that makes an institute employee E care more about their institute and contribute more to the institute, that makes a reviewer R do a better job on a review of a paper that they might be reviewing, and that makes a citizen take actions towards perhaps improving sustainability and increasing the chances of survival of our pale blue dot. But this is intrinsic and it's private in our model and not known to others. It manifests perhaps as actions, but often the general public do not get to know the level of the intrinsic motivation except through the actions A of the individual. There is this social norm though. The prevailing social norm is that voluntarism is good, working towards sustainability is good, pro-sociality is good. Not only that, we actually care that my colleagues care about what I do. So I care that my colleagues know that I care. Okay, so that's a tongue twister. I care that my colleagues know that I care. Okay, so somehow that matters to me. If I have high intrinsic motivation, I do some things perhaps to optimize the utility, but I also would do perhaps more if I know that my colleagues know about what my intrinsic motivation is. And so this is the social network, and maybe we can leverage the social network. This is often done. For example, it is often done to perhaps increase good behavior. I'll give you one example. You form a buddy with perhaps another person that goes to the exercise room, and the two of you do it together. And you do this together because I think it's essentially motivation to you. If you miss a day, for example, then missing for that day is sort of something that you would not like to. You have to face your friend the next day when you missed exercise, and therefore I think having this buddy system, the network, is something that can be beneficial. It can essentially make people do things in a positive way. It can happen that there are also negative consequences of this, but there are also important positive consequences of this network. And so maybe we can do this. And here specifically I'm looking at something called the reputation, right? I care about the reputation that I have, that perhaps I would like people to think that I have high intrinsic motivation towards pro-sociality. So why don't we leverage the social network, and why not make public the actions that people take? The action that you took on the review, the action that you took to perhaps help somebody, the action that you took to maybe mentor a junior faculty, perhaps wasn't made aware to the entire community. And if you make it known to the entire community, then maybe it might increase overall pro-social activity. I might then be more pro-social. Okay? And this is what is called reputation benefit. And let's see how to bring this into our model. Modeling reputation benefit. What the designer, now here it's, once again we are speaking about sharing information and so on. That's where the information design comes. What the designer is doing is taking these actions that each individual has done, which the designer knows, which perhaps the reviewer, editor knows, make it available, not in a way that compromises the review process, but in a way that enhances people's reputation. The designer makes public all the actions that are taken by the individuals. For example, if these are donations, the designer could say that such and such a person donated to this particular eye camp. Such and such a person donated this much to the eye camp, and so on. Society is curious. When you give all of these things, we always order where people stand, what is this person's pro-sociality, and so on. We always want to infer a particular agent's position in the intrinsic motivation scale. The intrinsic motivation is something that's hidden, but in the example that I gave, the actions were exactly the same as the intrinsic motivation. And effectively, you can tell the intrinsic motivation. But there are other situations where you might not be able to tell all, and I'll come to that very soon. And remember that an agent cares about what society or others think about this agent. And therefore, we'll modify our model to have a little extra term, which is the reputation benefit. There is this original AIWI, which comes from the intrinsic motivation. There is the cost, 1/2 AI square. And then there is this next term, or some EWI given some things. That's what is called the reputation benefit. It's what society thinks, knowing the actions AI of this individual and also all the others. You're always looking at this individual in the context of others. This person donated this much rupees to the ICAM. This person donated this much rupees to the ICAM. And you're looking at what is this person's intrinsic motivation given a donation of this much rupees and all others donated whatever they donated. And so that sort of gives an indication to others what the intrinsic motivation is, which we write as this. It's what in probability terms we call a conditional expectation. It's what society is able to infer about your intrinsic motivation based on your actions and all the others' actions. And the reputation benefit is turning this into something that is comparable with the intrinsic motivation WIAI entity with the cost 1/2 AI square. And so the R there is sort of turning it into rupees in some sense, the reputation, a multiplying factor that turns it into something that can be compared. And then you can put it there and add it. And so what each individual is doing in this new situation where information has been shared is the AIWI, the cost, and then a reputation benefit that comes from the sharing of information about how much activity or pro-sociality, pro-social actions an individual has done, coming from the society's curiosity to understand where this individual stands on the intrinsic motivation. And so this is the new model, and this new model perhaps we'll have to analyze this particular model. Sometimes when you do this, things can become worse without this reputation benefit, without providing this information. Maybe the pro-sociality actions were the same as the intrinsic benefit, and so you got some distribution. But maybe things got shifted in the other direction by virtue of this. We'll have to worry about that, for which we'll have to analyze. We analyze by looking at what are called equilibria. Okay, so here there is actually an interaction. So do I choose this action or do I choose that action? If I choose this action, my colleagues here have chosen the other action. This will be presented to everybody else. Everybody will look at this and they will know that I have given less than the other person. What will they think? Maybe I should give a little bit more. That's sort of the thing that we are essentially looking at and enabling and using to leveraging to increase the actions that individuals would do. So we'll have to understand where people will settle. And this involves identification of what is called an equilibrium. So we have to calculate that as well. And also we'll have to check whether it is actually better or have we made the situation worse. Are more people shifted towards sustainability or not, and so on. So here are some more observations. So I've written the utility once again. It's a simple social network where you're essentially looking at everybody gets to see everybody else's actions. Often it's not that simple. For example, if you make an action, not everybody in this room can see that action, but only your neighbors can see. And so here there are interesting questions that arise where if your visibility is only local, those are things that are open and need to be understood, and things might dramatically change in those situations as well. But we are looking at something where if you contribute, let's say 50 rupees towards this ICAM, everybody will be able to see that you contributed 50 rupees to the ICAM. So it's what is called a complete network or a complete graph. We are making a public announcement of all the actions taken by every individual. And so everybody gets to see it. And that might be something of concern, and I'll come to that. Now, you can go back to one of the things that whenever you have a model like this, one of the things that you should always check is, do I recover original results? Is this something that is off? Because if by a way by which you can turn this new system into the old system, your new solution must match the old solution. And that's the situation when you set R equal to 0. If you can't convert the reputational benefit into something that's comparable, or it always converts to 0, that's the case when R is 0, then we are back to the original case and the AI is equal to WI. So this is in some sense general. And if R is positive, that's the situation when there is positive interaction. And our hope is that when R is positive, things improve. There is positive reputational benefit. What this does is it basically makes people interact with each other, because your decision now depends on what your neighbor would do or what somebody else in this room would do. If that person would possibly donate 75 rupees instead of 50, then maybe you might think towards jumping and contributing a little bit more than the 50 that your intrinsic motivation might have pushed you towards. Is it resulting in these actions being larger than before? And those are things that we need to check. And when you do this analysis, and the analysis is actually something that 12th standard students can do, but it will be something that will be a page, and therefore I will skip it, and I'll be happy to speak about it for those that want to know about it. But yes, people are nudged in this system. The equilibrium actions that people take is something that can be described. And here is a full description of this. Assume that the original distribution of intrinsic motivation is something that everybody knows. And it's something called common knowledge. I'll not dwell into that. You know that others know that this is the distribution, and you do this in a recursive fashion. So let's say that everybody knows it and it's sort of common knowledge. Then there is a new equilibrium for this nudged system, for this reputation game. And this new equilibrium, for each individual that has a certain WI, you can find out what the new action is. And I would direct your attention to the first graph on the left. The first graph on the left has a Y equal to X line, which is the same as A equal to W line. That was the previous situation where there was no reputation benefit. If you had intrinsic motivation WI, your action would be AI, which is W equal to WI. But now what happens is that if there is an individual that would have this prosocial action earlier, thanks to a WI, then that person's action would be lifted up now, contributes more, does more prosocial action. And for each individual, the lift is different, but the lift is something that is positive. And those that are on the lower end are somehow lifted as much more than perhaps those at other places at higher levels of prosocial action. However, the lift is monotonic. So if someone has a higher intrinsic prosociality, then the lift for that person is higher. But the marginal lift is in fact higher for those on the lower end. And that's actually positive news, because it's saying that people are nudged towards more prosocial actions. Let's look at some additional remarks. I want to re-emphasize that this is a simple social network where everybody knows everybody else. F is common knowledge. And you're revealing what action each individual has taken. And this can raise privacy concerns. Maybe when I donate the 50 rupees, you can tell something about what I have donated, but not the exact amount. Because maybe this then has some impressions that gets created, and you're a little shy about those things as well. And so revealing actions may raise some other issues, and we have to worry about that. So maybe what you can do is then do a different design. A design that says not what each person's contribution is, but maybe this person contributed more than 50 rupees, and this person contributed something but less than 50 rupees. In the context of donations, that would be like a diamond sponsor. This person is a diamond sponsor. This person is a gold sponsor, and so on. So this is just a quantized version of the previous one. and what happens in this particular case. Again, you can come up with a model for this, and the situation is very interesting. And this is the situation. This picture sort of tells exactly what the new equilibrium is. The picture here, the original picture is where the Wi equal to Ai. That's the one which is the solid line, and then in between there is the dotted line. So let's look at it in the context of donations. Those that have contributed 50 rupees or more. Okay, that's what is indicated. So everybody knows whether you have contributed more than 50 rupees or less than 50 rupees. That announcement is made. What do you think would happen for those that intrinsically would have contributed more than 50 rupees? Do you think they would provide anything more? It would already be the case that you would have told, the announcer would have told that they have contributed more than 50, and that's all the information that others would get. And therefore, these individuals that originally would have contributed above 50 rupees, they wouldn't contribute anything more. They would still contribute whatever they would have originally contributed. What about those that were contributing, let's say, 2 rupees or something like that? Well, for them to move to 50 so that others get to see that they have actually contributed 50 rupees or more, for them to provide that much, it's a lot of cost. Nominally, they would not have done that. And now, for them to get the reputation benefit, it's a significant cost. And therefore, perhaps they will not move. And if it is below 50, then they would contribute whatever they would intrinsically have contributed before. But what about those at 45? What about those at 48? They get nudged. So there is a small section that essentially get nudged. And they are the ones that are essentially pulled up. So they would have nominally contributed 45 or 46 or 47, 48 or 49. Now all of them will jump to 50 because they see value in the reputation benefit that they get. The main point of this is that this kind of nudging you can predict and you can see that it's happening. And the modeling, the mathematics behind it, it's very natural, but the mathematics that tells that such a thing happens is also something that's reassuring. Where did all of these things come from? It actually came from an experiment in reducing electricity consumption. There was a small community somewhere in California in the United States where there were a group of households, and this group of households, if they were individuals that essentially were they had reduced their electricity consumption, there was, at the end of each month, there would be a green sticker that was placed on the doors of these households with consumption below a certain green threshold. And so all in that community would know that this is a green household, that the consumption has been lower. Here, pro-sociality is when you go lower, when your consumption is lower. And so this model sort of explains that there are a few that are nudged, and it explains that consumption behavior. We actually conducted a similar experiment, and I was involved in this experiment, in Alua, near Cochin. And here what we did is, imagine your electricity bill that comes, along with the electricity bill, pay this much amount of rupees, 846 rupees or whatever you need to pay for this month. You also, in Kerala, I think it's bi-monthly, you also got what your neighbors were consuming or what others that were in the similar category as you in terms of consumption, what they did and how many people reduced over the previous month. And this sort of enabled a social comparison and a friendly competition for you to reduce your own consumption. And it was done in Kerala primarily because in Kerala, the electricity consumption the residential electricity consumption is the highest compared to any other state in India, our tropical weather being one of the important reasons. And we anticipate that this electricity consumption is only going to become higher and higher as affordability of air conditioners, etc., improve. And perhaps these social comparisons will enable us to move towards utilizing these comforts, but in a responsible way. There is also another issue, why information design? When I provide to these consumers that you have actually used less than others in your neighborhood, for example, then this person might say, well, this comes at a cost to this individual, a little bit of discomfort. The air conditioner is off for a few maybe 15 minutes every day and so on. Why go through it if I'm already in the better bracket, in the lower consumption bracket? And therefore, what information you give to these individuals is important, because if you give this information in a not well thought out way, then this person might start increasing the consumption. And so one needs information design to carefully indicate, perhaps, to carefully nudge behavior. And in this ALUA experiment, the social comparison, we actually had a randomized control trial. There were individual households that got this usage, and then also others that we just monitored without providing any such comparison. And here is the improvement between what is the control and the experimental or the intervention group. The negative here means that the intervention group was actually using more, but then the intervention group switched to reduced consumption and they became more green. And that's what we saw after. In the previous, in the pre-program period, we were just monitoring all of them. In the post-program period, the individuals that were getting this improved their consumption, reduced their consumption, while the others stuck to the same level of consumption, or at least that was the assumption. And so such comparisons help. And perhaps what we should do then is conduct these experiments in a more systematic way and get more reliable conclusions. So some concluding remarks. What we have done is we have exploited social norms to get some sort of immediate improvement. And this is immediate improvement in reducing consumption. And this is immediate improvement in the action profile. And going beyond, I think this opens the possibilities to use information feedback to perhaps generate a collective identity, create a collective awareness, and also create a collective conscience in some sense. Here are some possible directions. There are examples where it's actually better to be economical with the truth in some sense. And so you must design these mechanisms carefully, and that brings about the question of optimal design for maximizing aggregate pro-social actions. And I told you about the hotels and ratings example. The analysis that we have done is on a model that is too simplistic. Also, the analysis is a static analysis, whereas things are dynamic. I think that's a question for the researchers here. We've looked at a complete network. Again, that's too simplistic. We would like to extend this to other networks. The cost may depend on the number of users that take a particular action, or the cost may depend on the users themselves. Like, for example, for me to reduce my AC consumption by a certain amount might be a huge cost for me, and it might not be the 1/2 A square that we have used as common for everyone. And so each individual, the individuality might need to be taken into account. And also there are things like, this is what is called a unidimensional signaling, but there are multiple dimensions of signaling. And when you provide a common signal for these multiple things, then a phenomenon called crowding out, etc., arises. And one needs to design these nudge systems with care. With those, I would like to thank some people that helped me on all of these thoughts. One of them is Alexander Reifers, who was a postdoc at IAC. He's now at this place called UMT Atlantic in France. He's a faculty member there. And also this company called Clitix, which is an energy space startup in Bangalore. And they helped us conduct the experiment in ALUA. So thank you very much.
Yeah, thank you, sir. So it's time for Q&A. So you can just raise your hand and I'll come there with the mic.
Hello. So about sharing information from the pro-social point of view. So I have a different perspective on this side. Let's say we share information about other things. Like
Information of?
other things. Like nowadays we are sharing information about publications, which leads to this QS rankings and NIRF finance. So this leads to a different kind of game. So, and now people are realizing that all these games may not be good. So, I mean, how do you fit that into this perspective?
I think that's an important point. So the point is that don't rank everything. I think that's the point that perhaps you're making, and I think it's important. There are some things which are best left unmeasured, and I think those you should leave aside. But then there are certain other things that you can measure, and if you measure, you can improve. So I think we have to be a little careful about what we measure and what we don't. And actually, pro-sociality, intrinsic pro-sociality, measuring that, etc., are all things that border on, is this appropriate to measure or not? I think that's what you're driving at as well. So I think you have to be careful as to what you measure and rank and what you choose to keep as hidden. And that is a design question in itself. With respect to rankings, I think it's a very sensitive topic. It's best left out. Ranking of institutions and so on.
Yeah, sir. In the meantime, one question. So here you are assuming that intrinsically a person cannot be better over time, right? So that
Intrinsically, a person can be
cannot vary over time. I mean, the distribution of A cannot vary over time, right?
distribution of W, the intrinsic
Yeah,
motivation.
sorry. Yeah, W. Yeah.
Yeah. So yes, that is that is what I sort of highlighted as a static model, and therefore it is unsatisfactory. It explains for a one-time analysis and so on, but people improve over time. People also change their perspectives over time. So the WI is better modeled as WI of T as a function of time. And maybe in the morning I'm more pro-social, but not that much in the afternoon and things like that. I say morning and evening only from the point of view of saying that the mood varies and so on. And similarly, a person's preferences also vary with time. Therefore, that would be a better model, more complex model, and therefore the conclusions might be more specific. It can't perhaps be something that provide some sort of general picture. So here all of these things are these are toy models that help us understand some of these things, and then in reality we'll have to take into account all of these. And perhaps they lead to good questions. There might be good conclusions that you can come up with. At first sight it's a little more complicated, but one needs to sit and see whether good principles can be extracted from it. And I would say it's a good research question.
So in your equation, that AIWI minus half AI squared, this. So this, the expectation of a WI, that WI is actually measured from the other's point of view.
Yes,
And the
correct.
first
So
WI
you know the WI, but others don't know. And so what you're saying is, what do others infer about the WI given all the actions and in particular my action? So for example, let's say that we know that out of the 100 individuals here, how much each individual has contributed to an eye camp. Okay? And this individual has contributed this much. So from that, what do others think is my intrinsic motivation? And that I've written it as EWI, but it's others' inference of the WI. And that inference, this person is this pro-social, is an inference that others have been able to infer. It might be different from the actual WI, but that's the reputation that I get.
So that was basically my question, that the first WI and the inferred WI
May be different. Maybe. In general, they may be different. For example, if all I give you is that this individual has contributed more than 50 and that individual has contributed less than 50, then the the expected value of WI, that is others' inference, they must put everybody that has given above 50 at the same level of WI in terms of their inference as those that have contributed lower than 50. So all of them will have one level, all of the others will have another level. The way to say it in more advanced language is that EWI is measurable with respect to the A's that have been given. And if all I give you is two values, then the EWI can only take two values, one for this and one for this. And therefore, any user that's there with a different WI perhaps, but has contributed more than 50, the reputation benefit that that individual will see will be the same as another individual that contributed just T. In fact, all of these that jumped up are taking advantage of that. And that's why they jump up. We have to have a question from the students in uniform as well. Anyone, at least one student.
Hi, sir. Could you explain how to decide the parameters of a social model?
Could you explain, repeat the question, please?
Parameters of a social model.
Parameters of a social model. I think it depends on, there are different ways to model it. It really depends on what you're trying to understand about the model. So I'll say with respect to this model, here perhaps I would be interested in if it is a graph or if it is an interaction model where, let's say I want to use this. I want to then understand, is the graph fully connected, or is the graph something that's a complete graph? So I want to know whether each individual knows everybody else here and cares about every other individual's intrinsic motivation similarly, or do they care only about their neighbor and things like that. And so that would be a parameter that I would want to estimate. So in general, what parameter you estimate will depend on the particular problem that you're trying to solve. And here I want to understand the graph, and I would like to put that, I would like to get that. Another one that I would be interested in is, are all the individuals in terms of the costs similar? So I want to maybe different people have different cost functions. Another thing that I want to perhaps estimate is what is the R? That is the conversion of the reputation into perhaps something. So if this person does this much amount of action to intrinsic motivation, we have a map. But from action to a reputation benefit, what's that conversion? Is R 1? Is R half? What is that correct number? To what some people also don't care about reputation. What do you care what other people think? So there are individuals like that. Or what do I care what other people think? So the R may depend on various individuals. And then in a model that takes that into account, I want to understand what each person's care about what others think is. Or maybe I have the hypothesis that all of them think exactly the same way about others, but what's that value? So it really depends on the model, that on what you're trying to model, and from that you'll have to identify what the parameters are. Thanks for the question.
Hello, sir. I'm Guru Raj. I'm a final year electrical and electronic engineering student from Government Engineering College, Palakkad. So my question is related to the answer for the last one. How would you define the cost function?
So this cost function C of AI is 1/2 AI square is actually a convenient what is called reparameterization. So for example, let's say that I had some other cost function which sort of, the one thing to keep in mind is that as AI increases, it becomes steeper and steeper. The cost becomes steeper and steeper. But there are many functions that have the same property. For example, e to the power of AI is another function which is like that. Or e to the power AI minus 1, if you want to normalize it at when A is 0, the value must be 0. And things like that. Okay. But what you call AI, you can actually change it. This is what is called reparameterization. And this reparameterization can turn any such convex cost function into 1/2 AI square. It's just that in your new parameterization, what was 5 units might now be 3.5 units. And what was 8 units might be 4 units, and so on. And so when you reparameterize, you can turn it into this 1/2 AI square. So sometimes this works, and when this works, then you can go ahead. However, when you change this, there is the WI times AI that gets affected as well. So when you reparameterize, but you have to change your intrinsic motivation WI also accordingly. And perhaps there is a way you reparameterize that also. Sometimes it might work, sometimes it not. It won't. And if it doesn't work with the C of AI, whatever is the cost function, go and measure that. What's the cost of putting this much more effort? You can perhaps have a way by which you can evaluate it, you can measure it, and then use that C of AI. So, thanks for the question.
Good evening, sir. My question is, what usually motivates pro-social behavior?
What usually motivates pro-social behavior? In the simplistic model that we had, we basically turned it into something that's matched to an intrinsic motivation. So there are some individuals with higher intrinsic motivation levels, some other individuals with lesser intrinsic motivation levels. And the kind of question that we try to address is, we take it as given that there is a spread in this intrinsic motivation levels, and we then try to remedy the situation by trying to, I wouldn't say remedy, that's the wrong choice of words. We recognize that this is this, and this leads to these actions, and we want to improve those actions, and reputation benefit is something that we are using. But your question is somewhat deeper, and it's basically saying, why are perhaps some individuals so kind, so helpful, whereas perhaps some other individuals might provide some amount of help but not that much, and some others may not care about the other individuals. And also, all of these things, there is another complexity, that there are social circles where you might be extremely intrinsically motivated to support in that social circle but not outside, and so on. So it's complicated. In this question, I did not address that reality as to why that reality happens. But that's also something that we'll have to address. Why are people altruistic? Can you understand that? And if you understand it, again, it enables perhaps better.
No, sir.
I don't have an answer to that question.
I understand.
Yeah.
I understood. Thank you, sir.
Yeah, thank you. Thanks for the question. Our starting point is given that what we can do. But thanks for the question.
Hello, sir. My name is Garima. I have a question regarding, I'm trying to understand what this, how the game behaves when we add a lie in the experiment. A lie means, let's say if there are a big number of residents in that area for the electricity consumption experiment, and we add some lie that even though not many people have passed that threshold now, but we just show the picture to everyone that, see, 10 people have done better. And you get some motivation that if they can do it, others can also, get motivated.
Yeah, okay, so let's look at it this way. I'm just going to articulate it in a slightly different way. So there is the designer that's actually sharing this information. And let's say that the designer is not truthfully and honestly implementing the protocol, but perhaps is paltering with the truth and saying that more than, when it was actually, let's say, 40% of the people donated more than this much, the designer says actually 50% donated more than this much. How robust are these schemes? Is it robust to that, and so on? I think when such a thing happens, it changes the situation. It depends on to what extent the individuals in the system know that such distortions can happen. Let's call that a distortion. To what extent can such distortion happen? Sometimes the distortion is important. Okay, I'll give you an example. The fact that you have not told how much each individual has given, but you're only told that this individual has given more than 50 rupees, okay, to the effort, to the collection drive, for example. That itself is a modification of what the actual individual has given, right? It's quantization, and so by this quantization, you have added noise. In the other case, you can say that it's a different kind of noise, right? So you can ask, can I add noise? And when I add noise, what happens? I've already added noise by quantization. But the quantization noise is something that we accept philosophically. Right? You have not changed the facts. You're only reporting that this person has contributed more than 50, but not what the exact amount is. And by that, you're essentially giving some advantage to some and not so to the others. You're not giving the advantage to those that have contributed a lot more. There's another way by which you can do this, and that is when a person has donated WI, you say that what I'm going to report is a noisy version of that. I'll add Gaussian noise. Sometimes it will be positive, sometimes it will be negative. So you could do that also. I think whenever you do that, we typically do not accept, we lose trust in the designer.
Yes,
And therefore, the designer is careful not to do such things. However, from a modeling perspective, if all the people have to participate and take actions, and there is a designer that palters with the truth in this way by adding noise, etc., then there is a mechanism by which you can account for it. You can't undo it completely, but you can say that if the person is adding noise in this way or is distorting information in this way, and you have a statistics associated with it, for example, it's Gaussian noise with mean 0 and variance 1, then you can do some things about it. For example, differential privacy, many of you might have heard of this particular phrase if you're working in data sharing mechanisms. This is a mechanism by which you distort the information and share that distorted information. So it's a way of distorting, and you're adding noise, etc. So it's in some situations it's all right, but in some other situations it might be a no-no. For example, in the donations context, it's an absolute no-no to say that the added noise approach is a no-no, because you might reorder individuals, and that's something that we frown at.
If it is not verifiable, and if we are not, I'm just trying to understand whether like a theoretical point of view or not, like in modeling point of view,
From the modeling
not
point of
concerned about the
ethics,
ethical
yeah.
or those things.
So from the modeling point of view, what you would do is, if I know that the designer is adding this type of noise or is changing things or modifying things in this way, then I can account for that in the conditional expectation. So in that E, it's not only I know that the AI and minus A minus I. So that's the notation for what individual I has action the individual has taken and what others have taken. Instead of that, it's L of AI and L of A minus I. L is some noisy version of this. And you take the conditional expectation given this information. And so that's the mathematical way of handling it. And whether it is ethical or not are other questions outside of the purview of this mathematics.
Do you think the people will have like more motivation for it to
If
reduce the
it is
electricity
distorted,
consumption, let's say?
I think what would happen is that if such distortions come to light, it might backfire. There are other considerations that would come into the picture, and people will no longer rely on this.
What if it's hidden, completely hidden till the end of the world?
Completely hidden in the sense that you don't know it at all, that such distortion.
Yes.
Then I think you're fooling all the people all the time. And some
I mean,
wise
it's not-
person has said that you can't do that all the time. So.
It's okay. Thank you.
Yeah, if there are no further questions, let's thank the speaker and over to Sahili for the vote of thanks.
Thank you.
On behalf of IIT Palakkad Pale Blue Dot team, I would like to thank Professor Rajesh once again to traveling to the Palakkad and delivering such a insightful one and thought-provoking speech. I thank the audience for making this event successful with your presence, especially the Moyans Model Girls Higher Secondary School and Electrical Engineering Association of Palakkad Government Engineering College. I also thank Block Resource Center. I thank EWD and CET team for their support. I also, last but not least, I thank UBA and the district library for running this Pale Blue Dot program. Thank you.